So this concludes now the backwards phase of the algorithm. And just to recap, the forward phase takes an augmented matrix and turns it into row echelon form. Then the backwards phase goes that extra step further to make sure that you're all the way into reduced row echelon form. So now you might rightly ask the question, what do we do? How do we take this and extract the solution? And sometimes we're going to have parameters. This is an example of a linear system that's going to require parameters to express the solution. So for starters, we need to know what the variable names are. And actually, if you remember how this example started, we actually were not given any variable names, right? The example, I just dove right into looking at an augmented matrix. So, and remember, augmented matrices don't contain the variable names. So we'd actually have to have that extra bit of information. You'd have to know the context from which this augmented matrix arose. So how about we do this? Let's say that we will make up some variable names right now. So let's say that the first column corresponds to x1, second column corresponds to x2, and so on. So we've got all the way x1 all the way up to x6, and they correspond to the columns. Because you need variable names to actually express the solution. You need to know what the variables are called in order to actually write down the solution. So let's suppose that the linear system of 4 equations and 6 variables that we were given that gave rise to this gave rise to this augmented matrix was written in the variables x1 through x6. So now we can use those variables to actually express our solution. So let's go back down here and let's look at how we can do that. So this is not strictly mandatory, but I highly recommend that you adopt this approach that I'm about to show you. So we've already got our leading ones circled from doing the check that this is indeed in reduced row echelon form. So take every column that doesn't contain a leading one. So that's column 2, column 4, and column 5. Those variables are going to be assigned parameters. So x2, x4, and x5. Jot that down. These variables will be assigned parameters. Many students that I've spoken with in the past get to this phase and they just aren't sure exactly which variables they should assign parameters to. So that's why I'm taking the time to write this down, and you should as well. This is really how you decide that, right? Figure out where your leading ones are, and then take the variables that correspond to the other columns and give them parameters. So what we're going to do is we're going to say let x2, let's use the letter S for the parameter for x2. So that's corresponding to column 2. x4 corresponds to column 4, so that will be a parameter. I'll use the letter T. And then for x5, we'll use the letter U for the parameter. So S, T, and U are parameters. So let's clarify that now. For arbitrary, remember that's the word you can use to indicate that these parameters could be absolutely any real number at all. So for arbitrary S, T, and U in the reals. Or you could say for parameters S, T, and U. That would be also perfectly acceptable, but this is how I tend to write it. Okay, so that takes care of 3 of the variables, but we need to find out what all the variables are. So now we're going to one by one write out what the other variables should be. So now what I will say to do is go to the very last column and work your way to the left. So the 6th column, ask yourself, have we already dealt with this variable? No, because we haven't. We've only given parameters to x2, x4, and x5. So x6 has not been dealt with yet. So if it hasn't been given a parameter, that means this column contains a leading one. So go up and find the leading one, which is right here. And then take the row that contains that leading one and write out its corresponding equation. So we can go x6 is equal to 1/3, because that's the equation that corresponds to the 3rd row of this augmented matrix. And there you go. Now we've got our value for x6. So now we're going to call that one completed, and we'll work our way to the left. x5 already gave it a parameter. x4 already gave it a parameter. x3 we haven't dealt with yet. So this one needs to be dealt with. So again, if it hasn't been already given a parameter, you know that you're going to have a leading one. So take the corresponding row that contains that leading one and write it out. Write out the equation that corresponds to this row. So we're going to have x3 plus 2x4 is equal to 0, right? Because this is 0x1, 0x2, 1x3, 2x4, and then everything else is zeros. So that's why you get this equation. And now just solve for the variable that corresponds to this coefficient, which is x3, right? So solve for x3, and you're going to get negative 2x4. And go a little bit further, because x4, we have a parameter, right? We've got a parameter t for x4, so plug that parameter in here, and you're actually going to get negative 2t. Okay, so now we've got x3, so we've dealt with x3. Move one over to the left again, we get x2. x2 was given a parameter s, so that one's dealt with. Lastly, we go over to the very first column. This one has not, this variable has not been dealt with yet, so we're going to go up and find the leading one and write out the corresponding equation that underlies that row. So we'll have x1 plus 3x2 plus 4x4 plus 2x5 is equal to 0. That's what you get if you write out the equation that corresponds to this row. And do the same thing. Solve for the variable that this leading one corresponds to, which is the last one we have to deal with, x1. So solve for x1. Bring these three terms over to the other side by subtraction. And you'll get x1 is equal to negative 3x2 minus 4x4 minus 2x5. And then, just like we did over here with x3, we wrote solve for x3, we had the x4 appearing, so we plugged in the parameter. x2, x4, and x5, they all have parameters up here, so let's plug st and u in for these three variables. And then that's how we'll finish off x1. So we'll get negative 3s minus 4t minus 2u. And that's going to be our value for x1. So now, all that's left to be done is to summarize our solution. And you can probably visualize that if I were to just use the same approach that we've used in the previous examples in section 1.1 to summarize my solution, if I used, that is, if I were to use point form, remember what that looks like? I do an open bracket, I'd start listing my variables x1, x2, x3, x4, all the way up to x6, and I'd put commas in between, and then I would write out the values afterwards in a point as well with 6 coordinates. Well, with 6 variables, especially since one of them has a lot of material to actually represent, I might actually run the risk of barely being able to fit that in one line if I were to write it out carefully. And if I had a couple more variables, like if I had 8 or 9 or 10 variables, I'd very likely run out of room. So, and even if I didn't run out of room, it might be difficult to read. So this is where a different form comes in handy for expressing your solutions. You might want to use this form to express your solution. So this is called column form. And what we're going to do to summarize it is we're just going to write the variables vertically. So x1, x2, I'm stacking them on top of each other. x3, x4, x5, and x6. And I'm going to put big square brackets around them. Really what I'm doing is I'm writing a very tall, narrow matrix. This is referred to as a column matrix because it's a matrix of entries. The entries are variables, but they're still entries, and it consists of a single column. That's why it's called a column matrix. We'll talk more about that in section 1.3. Okay, so then I'm going to say this is equal to, and then I'm going to write another square bracket to write another column matrix, but then this time instead of writing the variables, I'm going to write what their corresponding values were that we found up here. So the first one, x1, we figured that out over here. It's negative 3s. It's negative 3s minus 4t minus 2u. Then go down the list to x2. Where's x2? That was a parameter, right? That was the parameter s. And then we have x3, which was negative 2t. x4, where's x4? x4 had a parameter t. x5 was the parameter u. And then x6, what was x6? x6 had the actual value 1/3. Okay, so that is how we can express our solution in a compact, concise form and also an organized form. Right? That's easy to look. Someone else coming in reading this, they don't want to have to sift through all of our work up here to find the variables. They just want to have it all summarized at the end. And also, we should Also remind them that S, T, and U were just parameters. They could be absolutely anything. So we'll say for arbitrary parameters S, T, and U, I like to say for arbitrary real numbers S, T, and U. So that's how I can express that. So this is how I can express the general solution to this linear system, and I'm going to just put a box around it too, because that's also a habit you want to get into and stay into. Get into and stay in this course, because typically the solutions to these problems are quite lengthy, and you want to, it's all the more important because of that to organize your solution at the end. So that's how we can complete that one.